3 hours per week. So if you look at the numbers of the weeks, the number of the week for each session, lecture we have 14 weeks, tutorial only 10, laboratory 4 weeks. So that's mean for tutorial and laboratory, total is 14 weeks. So every week have lecture, tutorial or laboratory. So I hope you can understand the implementation of this course. So for example, next week, if you have a tutorial, then we don't have laboratory work for either one. But we have to complete a tutorial for 10 weeks and laboratory work for 4 weeks. Okay, but for this semester, we will not cover laboratory for 4 weeks. I hope we can settle the laboratory work as soon as possible because we want to minimize our face-to-face session. So maybe probably 3 weeks only for laboratory work. We want to minimize our face-to-face session. Okay, then for course instructions, yes, of course, attendance is compulsory. Must attend more than 80% of the total contact hours. Okay, number 8 is one. This is the very important thing for today. Course evaluations. For the evaluation, it divided into 2 types, two category. First is coursework, and second one is final examination. So let's look at the coursework first. For the coursework, they have 1, 2, 3, 4 criteria. First is midterm. Term will give you 10% if you can score or if you can answer all the questions correctly. For the quiz, they have 4 quizzes. Total for these quizzes is 10%, which means one quiz is 2.5%. Lab test, you have one lab test, 10%, and this is the individual test. Have a one-to-one session with me. I will interview you one by one regarding your experiment. 10%, all my requirements. And then number 4, for the lab report, total marks is 30%. They have 3 reports that you need to submit. 2 individual reports, 1 group report. After this, I will show with you your group. I already created your group. So you will your laboratory work by group, but have to prepare 2 individual report and 1 group report based on the experiments. I said just now, for the laboratory work, they have 3 experiments, boils, and look back at 4 here, okay, have 3 experiments. So Boyle's law, refrigeration system, and mechanical heat pump. So based on this experiment, you need to prepare 2 individual report and 1 group report. I will explain later which one experiment that you need to prepare by group, report by group. Explain later during the laboratory work session. Okay, so for the lab report, the total mark is 30%. So overall, for the coursework, total mark is 60%. And for second category, it is a final examination. So for the final examination, total marks is 40%. One final exam for 3 hours. So total 100%. Okay, next, this is the schedule based on each week. One, well, we will have chapter number 1 for today, but not too long. It's very simple, just an introduction for thermodynamics. And then you can refer to this schedule. Hopefully we can follow this schedule, but based on my experience for this thermodynamic, we can cover all of the chapter, 6 chapter, probably during 10 or week 11. Rest, focus more on exercises. Okay, so the lecturer for this course, we have two, Dr. Muhammad Afizal and me, but Dr. Afizal is the moderator or coordinator, penyelaras. So he is the one who coordinate this course. Okay, so I think this is all the important thing that I want to share with you for teaching plan. Before we move to another thing, do you have to ask me regarding teaching plan? Before we move to the next item, apa pertanyaan so far? Suara saya kedengaran dengan jelas, eh? Okay, good. Okay, kalau tak ada, let's move to other item. I will stop sharing this one, and I will show with you your lab. Okay, can you see this one? Fine. So this is your group, and the member for each group. So please contact all of these, all of your friends for each group. Discuss with them. For section 2, section 3, and section 4. For today, the lecture is section 4, right? So section 2, I will contact them later on. For section 3, please find your friend as well. Saya pun dah letakkan, I already pick up one person as a leader. So ketua bertanggungjawab for the members. Okay. So anything happen, ulang dulu, eh? Nampak, eh? Okay. Don't worry, I will share with you all of these files. Yeah, you can this file you can get from Ulen. Okay. So please, I already uploaded all all of the files related with our course in Learn. You can get this list from the ULearn. Okay, for the laboratory work, for the lab session, inshallah, we start by next week on Tuesday for section 2 and section 3, and Thursday for section number 4. Okay, so please come to lab or makmal thermodynamics to start our lab or we start the experiment number 1. Okay, the thing is for ketua, for the leader, okay, macam ni. For the lab session, the attendance is very strict. I mean the number of person that can enter the lab are limited. For each session, only 20 students are allowed to do the experiment. So, for example, on Tuesday, section 2 and section 3, they have 6 group, right? So 6 group, if times by 5 students, that means they have 30 students. But the rule is only 20 students are allowed to do the experiment. So here, ketua, please select person, 3 person to do the experiment, to collect the data for Tuesday, for each session. Ketua must select only 3 students for each session, collect the data. Okay, so for example, section group 3A, okay, for example, Ahmad Zaim Ashraf, you as a leader, so you have to select 3 person. Sama ada you sekali termasuk, including you, Imran or Aiman, or you can select Imran, Aiman or Iqmal for the first session. Okay, the rest two just stay at your room. Okay, the rest two you stay at home. You stay at your bilik lah. Okay, only 3 person of each group must come to the lab, take the data, do the experiment and take the data, collect the data. After that, bring back all of the data to your college kediaman and then discuss this among your group member. Termasuklah 2 tadi yang tak hadir. Okay, faham eh? So that's for Tuesday. For the next week, another week, week number 3, next week is week 2, right? Week number 2. Next 2 week, week number 3, ketua, you have to select the another 2 person, including you lah, ataupun you nak select mana-mana yang lain. Tapi make sure yang 2 tak hadir minggu pertama, minggu kedua, they have to attend on week number 3. Okay? Dan cari seorang lagi, tambahan seorang lagi. To do the experiment and collect the data. Tak mahu orang yang sama, kena orang yang lain. Mungkin ada seorang yang akan bertindih 2 kali kena hadir. Ketua boleh lah, dia hadir 2 kali, 2 session dia hadir. Okay, faham this is how we do the lab session. Masuklah section 4 section 4 on Tuesday. Section 4 we have 6 group for Tuesday. So for each group, up 3 person to do the experiment. The rest two stay at your home or stay at a college kediaman. Just stay, and then the first 3 person, you have to come to the lab and do the experiment, as well as collect the data. After that, bring the data back to your college kediaman and discuss among your members team. Among your members, among your team, okay, among your members. So for next week on Tuesday, the lab session is 3 hours. Okay, lab session is 3 hours. So for each lab session, hours is 3 hours. Okay, session is 3 hours. So I hope you can do 2 experiments. Okay, do 2 experiments. So for week number 2, you do 2 experiments. For example, Boyle's and refrigeration, Boyle's law and refrigeration system. Section 3A, you do 2 experiments. 3B also do 2 experiments. 3C also do 2 experiments. So for the next coming week, tinggal satu saja lagi lah lab you kena siapkan. Okay, so that means our lab session only 2 weeks instead of 4 weeks as mentioned or as written in our teaching plan. So we want to minimize our contact hour, face-to-face contact hour. So we want to finish. Want to complete our lab session as fast as early as possible.
Sorry doktor, ganggu.
Yes.
Kita orang balik minggu depan.
Balik ke mana?
Balik UTM. Pasal kita orang masih dekat rumah lagi.
Oh, ya ke?
Pergerakan balik mula 15.
Balik 15.
Dah start balik 15.
So, okay. So, week 3 lah, kita start.
Week 3 mungkin boleh.
So, kebetulan, correction, the laboratory work will start on week 3. Not next week, but next 2 weeks. But implementations, as I mentioned, we will do as I mentioned just now for the implementation. So week number 3, all of you are in college kediaman. So ketua pick up 3 person for lab session. Lab session 1, experiment 1 and experiment 2. So the rest two, you stay at your bilik. And for week number 4, tak boleh juga. 16 hari bulan cuti kan? 16 hari bulan cuti. Tolong confirm dengan saya 19 hari bulan cuti ke tak? Saya cuti hari Rasul. Siapa orang Melaka sini?
Cuti doktor, cuti. Mari rasa.
Hari bulan. So Tuesday book for Tuesday 19 hari bulan. Okay. Let me think.
Doktor.
Yes.
Saya ada satu lagi soalan. Untuk lab ni kan, kalau macam ada orang yang balik lambat, balik untuk fasa, dia ada macam banyak fasa doktor. Macam sekarang ni fasa 1 minggu depan. ada juga yang balik masa fasa 2, fasa 3 tu sebab diorang lambat dapat vaksin kan. So, yang mana contoh kalau grup diorang tu tak cukup untuk 3 orang, tapi yang dah balik tu 2 orang, so 2 orang tu je lah pergi kan. Sampai yang dia punya group mate tu balik, betul tak?
Betul. Ketua bertanggungjawab di sini untuk tentukan siapa yang hadir waktu lab session.
Oh, okay, baik.
Dan ketua pastikan the person who are going to attend that session must complete course two doses.
Alright.
Yang tak complete tu dia tak boleh hadir.
Okay, faham.
Ketua kena cari pengganti.
Okay. Thank you, Doktor.
So di sini saya serahkan tanggungjawab kepada ketua untuk tentukan pelajar yang akan ataupun ahli kumpulan yang akan menghadiri lab session pada satu-satu masa. Okay. Maximum 3% for each session. Okay. Maksimum 3 orang pelajar daripada setiap kumpulan hadir untuk lab session. Kalau 2 pun tak apa. Kalau 2 yang mampu hadir, 2 saja yang hadir. Tapi kalau seorang, kesianlah Kalau dia seorang je hadir, lagi 4 tu tak hadir, kesianlah pada seorang tu. So ketua bertanggungjawab untuk aturkan ahli kumpulan yang perlu hadir pada setiap sesi. For the official date or official week to start our lab session, I will let you know later on. Since you are still in your hometown right now, so it's impossible for us to start on next week. So maybe next week, okay, week number 3, our lab session, maybe tentatively on week 3. Okay, so that's for lab session. Do you have any question regarding or related this lab session before we move to short lecture for today? Just an introduction of thermodynamics. Ada apa-apa pertanyaan ataupun kemusykilan? Okay, tak ada. I will stop sharing this slide. Share with you our lecture note. Boleh nampak slide saya? Okay, this is our first meeting, our first lecture session for this semester. Thermodynamics DMCT 2133. For this semester or for this course, are going to learn, or we are going to discuss thermodynamics for 6 chapters. Start chapter number 1, concept definitions and basic principles. Chapter number 1, they have 6 items going to share with you. First one is introduction, then we will look at the system, properties and processes. For the system, they have 2 types, closed and open. Of closed and open system will be discussed in topic 1.3, and then we will look pressure and Bourdon tube. After that, 1.5, we have barometer as temperature. Okay. The objective for this chapter, at the end of this chapter, I hope all of you guys are able to first define the thermodynamics term and relate them to the usage on thermodynamics area in your daily life. Number 2, I hope you are able to review the basic units in engineering. And last but not least, understand and clarify the terms used in thermodynamics. So please make sure you focus on my because they have several terms or new terms for you are going to learn in this slide, and these terms along this semester. So as an introduction, we will look at the terms of thermodynamics. Actually, thermodynamics terms come from Greek. Term means heat and the dynamics means power. So if they combine both of these terms become as one term, thermodynamics, whereby of this thermodynamics or the thing that we are going that are inside the knowledge that are inside this term is related with heat and power. So basic science, it is a basic science that deals with energy. I said just now, they have 2 terms, thermodynamics. So thermal is heat, power, so that is a basic science that deal with energy. All know that energy is created nor destroyed. So I assume that you already know this sentence, this statement: energy is neither created nor destroyed, which means we cannot create the energy or we cannot destroy it, but we can convert or transform the energy from one form to another form. So since the energy can be transformed from one form to another form, the energy itself is a conserve. Tak hilang ke mana-mana, dia tersimpan, conserve. So that's why the scholar on thermodynamics field come up with one principle, conservation of energy principle, and this principle the first law of thermodynamics. So basically, thermodynamics can be classified into 2 types. The first is classical thermodynamics. Second one is statistical. For our level, focus on classical thermodynamics. Statistical is more on advanced level. So later on, if you proceed your study from one level to another level, then you statistical thermodynamics. So this is the meaning of classical thermodynamics. It is a macroscopic approach to the study of thermodynamics that does not require a knowledge of the behavior of individual particle, which means not focus on the particle, the individual particle. Individual particle here means atom, molecule, ion, electron. All of these are the individual particles. So we not focus on that. We just focus on the macroscopic. Macro means bigger, quite bigger than micro. Macro, as I said just now, atom, molecule, all of these particles are on microscopic approach. But for us, for our level, since we focus on classical thermodynamics, we'll look at a macroscopic approach. It provides a direct and easy way to the solution of engineering problems and EDC specs. So as I said earlier, for this thermodynamic, the MCT 2133, it's not complicated or too difficult. It's quite simple because we just look at the fundamental basic knowledge, focus on microscopic approach. Next, for the statistical, the second type of thermodynamics, it is a microscopic approach. Very small. We look at a very small approach, a very small particle based on the average behavior of a large group of individual particles. So here, for the statistical, we analyze the individual particles, how the atom or how the molecules move from one position to another position, whereby the particle move, it brings right kinetic energy, for example. So for statistical, we analyze the individual particles, not the macroscopic, but in terms of micro. Micro is very small. Analyze the atom, molecule, the ions. Okay. Next, conservation of energy principle. Since energy cannot be created nor destroyed, can transform from one form to another form. So they have one principle that related to the statement, which is conservation of energy principle. So here, during an interaction, energy can change from one form to another form, but the total amount of energy remain constant. So that the last sentence, if you look at the last sentence, the total amount of energy remains constant. Or in other words, it is conserved. Kita simpan. Okay, dia tak hilang. Energi tersebut tidak hilang. Tidak hilang lah. Dia akan tersimpan dalam bentuk yang lain. Example here, if we look at this figure, this rock have 10 units of potential energy, but 0 unit of kinetic energy. Why? Because the rock is the top of the hill. Okay? Because the potential energy is maximum compared to the kinetic, 0. This rock is not moving yet. So once the rock start drop or move downward, kinetic energy. So a portion of the potential energy transform into another energy. So they have 7 units of potential energy and 3 units of kinetic energy. Why? First, potential energy is 10 units because of PE or potential energy equal to S times G times H. Kan kamu pernah jumpa kan? MGH. So at first the height of the rock is maximum. That's why 10 units. Okay. Once the rock moving downward, move to downward, the height become smaller than the previous height. So ketinggian dia dah menjadi rendah, berkurang berbanding ketinggian asal. So that's why the potential energy reduce from 10 unit to 7 unit because of the height. The level of the rock smaller compared to the initial state for the first state, keadaan pertama. So that's why the potential energy once the rock moving downward is smaller compared to this one. So the rest of the potential energy, the remaining 3 units transform into kinetic energy. Akan berubah kepada kinetic energy because they have a velocity there. 3 unit yang hilang daripada potential energy transform to kinetic energy. Energy cannot be created nor destroyed. We cannot destroy the 3 units of potential energy tadi, okay? But it is transformed another form of energy, which is kinetic energy. So energy cannot be created or destroyed. So therefore, from this statement or from this phenomena, this equation can be came out. Minus E out equal to delta E system. E in means initial. Okay, initial atau E1 lah. Okay, E1. E out means E number 2, E final. Yang kedua. So E asal, total energy at the initial state, keadaan asal is 10 units, right? Because PE 10 unit, KE 0. So 10 unit minus E out E yang kedua. 7 unit minus 7 unit plus 3 units, still 10 units, right? So 10 minus 10 equal to 0. So delta E equal to 0. So here, from this phenomena, come up with law, first law of thermodynamics. Of this law, it is an expression of the conservation of energy principle. An expression of conservation of energy principle. So based on the figure, statement for the first law is an expression of conservation of energy principle. So conserve energy is conserved. It's not, it cannot be destroyed. The first law asserts that energy is a thermodynamic property. Okay, next. Okay, next. Next is the second law. As I said, in thermodynamics, they have two important law or two main law. First law of thermodynamics and second law of thermodynamics. For the second law of thermodynamics, it's mentioned that it stated that it accepts that energy has quality as well as quantity. And actual processes occur in the direction of decreasing quality of energy. The previous law just said about the quantity, just deal with numbers. Tadi kan, 10 minus 10, from 10 to 7 and 3, right? Potential energy first potential energy is 10 and first kinetic energy is 0. Second potential energy is 7. Second kinetic energy is 3. Right? So we deal with numbers. Numbers here means quantity. But for the second law, state that it has a quality as well as quantity. That's the quantity, numbers, but it has a quality. That is what the second law stated. Second thing, the second law stated that the actual processes occur in the direction of decreasing quality of energy. For example, the 1.3 here flows in the direction of decreasing temperature. This is a common sense. Always face this phenomena in life, right? You have a cup of hot coffee. Slowly, the temperature of our hot coffee become colder, right? It's decreasing by time, as shown in this figure. Because heat is transferred from hot coffee to our environment, whereby the temperature of the environment is 20 degrees C or 25 degrees C. So heat is transferred from hot place to cold place. So that's what the second law stated there. Actual processes in our daily life occur in the direction of decreasing quality of energy, right? So here, from this phenomena, you can imagine that this is what we call as a quality of energy. Decreasing quality of energy. High quality energy here means that hot region, hot place, hot region. Low quality of energy is cold region. Cold region. So this is what we call as a quality. Boleh nampak kan? Direction of decreasing quality of energy. So quality, if later on if I say quality of energy, your mind, you know that quality of energy means high quality where the region has high temperature. Low quality of energy means the region has low temperature. So the process occurs from high temperature to low temperature. So please keep in your mind the meaning of the first law and the second law of thermodynamics, because later on in the next chapter we will look, or we will learn more of first law and second law. Learn more on that. Now, for today, we just look at the meaning, the definition, not meaning, the definition of the law. Baru definasi. Of the law. Later on, we will look at more on the first law and second law. Even we will do some analysis based on first law and second law. Okay. So a cup of hot coffee left on the table eventually cools. This commonly happen. Nature. Quality, as I said just now, quality of energy means high temperature energy transferred to lower temperature energy. How we the mean of quality of energy. So for second law, we deal with quality and quantity. For the first law, we deal only with numbers. Okay. Next, here they have several applications that are related with thermodynamics. First one, a house that has solar collectors, a shower, hot water, cold water, changer, pump. All of this system deal with thermodynamics. Then second, refrigeration system. So of course, we have at least one in our house system. System also related with thermodynamics, and interestingly, in this course, learn about the mechanism of refrigeration system, how the system works. Then in chapter 5, if I can. And then they have boats, aircraft, power plants, wind turbines, AC system, as well as industrial applications. So all of these activities in nature involve some interaction between. So anything system that interacted between energy and work is thermodynamic, is in thermodynamic field. Apa-apa saja, any system in our life that are interacted between energy and work can be called as thermodynamics. We will look at several terms in thermodynamics. First one is energy. So for the energy, they have two types of form, two form of energy. First one is macroscopic and second one is microscopic. For the macroscopic, a system possesses as a whole with respect to outside reference frame. For example, potential energy and kinetic energy. In terms of microscopic, we deal with potential energy and kinetic energy of the system, which means big scale, microscopic scale, big scale. However, for the microscopic energy, it is related with the structure of the molecular. Example, the degree of molecular activity. Deal with small scale. For example, molecular translation, molecular rotation of the molecule, electron translation, and molecular vibration of the atom or molecule. That's microscopic energy. So for our level, again, since we learn classical thermodynamics, so we focus more on macroscopic energy, potential energy and kinetic energy of the system, not of the molecular structure. Okay, then next is dimension and units. Revision for you. Learned before this in high school. Dimensions are the names that characterize physical quantities. But for units, those arbitrary magnitudes and names assigned to dimension, which are adopted as standards for measurement. So here they have two types of dimension. First one is fundamental or primary, derived secondary or units. For the fundamental or primary units, primary dimensions. They have only 5: time, mass, length, and temperature, and current. But for derived, they have too many. Just listed on 5 dimensions or units for the secondary: velocity, force, pressure, energy, and frequency. So basically, the derived dimensions come from fundamental dimension. For example, velocity come from times and length. For the force, also come from times and length. Sorry, mass, length. Mass and length. Okay, next, standard prefixes and in SI units. So we have several standard prefixes in SI unit, start from tera until pico. But usually we deal with kilo, mega, gram, and centi, meter, and micro. But sometimes, special case, tera, this one, okay, smallest, and nano. Okay, next, we will look at weight and mass, the difference between weight and mass. Before we know the difference, we have to look at the difference. So mass is an amount of matter, right? Weight is a measure of how much force is applied to the matter. Always confused between mass and weight in our daily life. Sometimes we ask our friend, how much your weight? How much your weight? That is not correct. Correct, what is mass? Mass is an amount of matter, kilogram. Weight is a measure of how much force. Okay, force means they have a acceleration there. Is applied to the matter. So your mass is the same on the Earth and on the Moon, but our weight often are not careful to make a distinction between mass and weight, as I said just now. So here weight is mg, mass time acceleration. So the unit here for weight is ton. Mass is of course kilogram. F equal to ma, most of us know about this Newton's law, Newton's second law of motion. F equal to ma. F is force, m is mass, and a is acceleration. On the surface of the Earth, we usually call the acceleration as g, gravitational acceleration. So on Earth, the value of g is 9.8 per second square. 32.17 is in terms of feet per second square. Since we refer to SI unit, so we use 9.8 per second square. Okay, here we have short or simple exercises. A man has a mass of 63 kilograms. So first, find the weight of this guy on Earth and on Moon. So on the Earth, the gravitational acceleration is g, and the gravitational acceleration on Moon is over 6. It's very simple. You want to find weight, right? Weight equal to mg. W equal to mg, and as we know, mass of this guy is 63. So G is 9.8. So 63 kilogram times 9.8 meter per second square. That is weight on Earth. However, on Moon, the weight of this guy is different, since the gravitational acceleration is not same on Earth. So, by using Newton's law, the second law of Newton, F equal to ma. So the weight of this guy on Earth is 618.03 Newton. On Moon, the weight is 103.01 Newton. So lesser than on Earth. Okay, so from here, I hope clear now the difference between weight and mass. Okay, next 1.2, look at several terms in thermodynamics. For the first one, let's look at the first three terms: system, surrounding, and boundary. So please focus on this, because later on you will see this term always. You will always see all of this term throughout this semester. First one is system. System is a quantity of matter or a region in space chosen for study. So they have a figure there. System is the blue one, the blue region. The blue region is called as a system. Surrounding, the mass or region outside the system. So anything outside the system is called surrounding. Number three, boundary, the real or imaginary surface that separates system and surrounding. So in between system and surrounding, the pink line, the pink region is boundary. If we apply all of these terms in our daily life, if we apply all of these terms in our daily life, we have a room, right? We have a room. For example, now you are sitting in room, your room. So they have a wall surrounded. You are surrounded by the wall. So your room is the system. The place where you are sitting right now in your room is a system. The wall that are surrounding is boundary. Outside your room, anything outside your room is surrounding. This is how we apply this term in our life. System, surrounding, and boundary. Okay, so please make sure you understand very well the definition of these terms, because we are going to use for the whole course: system, surrounding, and boundary. Okay, next, the system itself is classified into two. The first one is closed system. Second one is open system. So from this figure, you can actually get some idea the meaning of each system. Okay. look at the figure, focus on this figure. So from this figure, actually you know the difference or the meaning of closed and open system. So for closed system, energy can be transferred in and out. Energy can be transferred in and out. Closed system, it doesn't have any door. Our common life, we can say door, right? Have any door into. But for open system, energy and matter or mass can be transferred in and out. Matter now or mass now can be transferred in and out since they have inlet or door. That is the difference of closed system and open system. So by right now, we have known the definition of the system, closed and open system. Okay. For a closed system, sometimes can call the system as control mass system, which means the amount of mass inside the system is fixed. You can say, can call closed system or control mass system. They are same. No matter or no mass can be transferred across the boundary. At the figure, only energy are allowed to transfer in and out of the system. Because if you look properly along the boundary, you don't have any inlet and outlet. Tak ada pintu keluar dan masuk. So mass cannot be transferred in and out. So therefore, the volume of the closed system is not constant. The volume of the system is not constant. They have an example for this system, piston system. For piston system, the boundary is moving, right? The boundary is moving up and down. So therefore, the volume inside the system is not constant. Piston system is one of the example for closed system. Next, for the open system, they have another name for open system, control volume. Control volume. The volume is fixed. And tadi, for the closed system, volume is not fixed. Now, volume is not fixed, right? It's not constant. But for the open system, the volume is fixed. So that's the meaning of the control volume. So for this system, it allows both mass and energy transferred across the boundary. So mass can be transferred in and out for this system. Of course, yes, energy can be transferred. Even the boundary is closed, energy can be transferred in and out. So therefore, for the open system, both mass and energy can be transferred in and out. So for the open system, the mass is not constant. So remember that mass is not constant for the open system. They have several applications that are using open system as their system. For example, pump, compressor, valve, turbine, and many more. Next, energy. This is a revision. Actually, we already discussed about energy at the earlier of our slide discussion. Forms can be divided into two categories: macroscopic and microscopic. Macro respect to some outside frame. So we deal with the system, but microscopic big system, but microscopic related to the molecular structure. Still system, but in terms of molecular form. Okay, this is an example of macroscopic energy, potential energy, and kinetic energy of this system. APE equal to mgz or mgh. M is mass, g is gravitational acceleration, z or h is the height. But for the kinetic, Ke equal to mv square over 2. 1 over 2 times mv square. M is mass, v is the velocity. So once the ball start moving, it's kinetic energy. For the first one, this lady hold the ball, some at a certain position. So at this position, the potential energy is maximum. However, Ke or kinetic energy is 0, right? Because the ball is not moving. So once the lady leave the ball, potential energy decrease, energy increase, right? Okay. Then we have a short quiz now. Here, calculate the P potential energy. As we know, the formula for PE is mg. Mass 60 kilogram, G is 9.81 meter per second, and H height is 2 meter. So before you calculate the value of potential energy, please make sure the units are in SI unit. SI unit. All of the units are in SI standard or SI unit. Mass, yes, it is kilogram, SI unit. Gravitational area, meter per second, yes, of course, it is SI standard units. Plus 1 meter also in SI unit. So once you have confirmed all of the units are in SI standard units, then you can solve the problem. Calculate, get the value. Not convert the unit first to SI standard unit. Otherwise, get wrong value or wrong answer. Okay, ni jawapannya 1.18 kilojoule, or you can write as 1177.2 joule. But usually, for the energy, the SI unit is kilojoule. Kilojoule, okay? So please convert to kilojoule. Next, microscopic kinetic energy. We still deal with kinetic energy and potential energy, but for the microscopic approach, look at the individual molecules. Kinetic energy of the molecules, potential energy of the molecules, or even binding forces. For example, here, chemical energy, nuclear energy, etc. Okay. Both macro and microscopic forms of energy are static and be stored in the system. can store the energy and transform the energy from one form to another form. Okay, next, total energy. This is the important terms that are usually used in thermodynamics. Total energy. The effect of magnetic, electric, surface tension are negligible. What means? Baikkanlah, that are negligible. The total energy of a system. The total energy of a system comprises of only the kinetic, potential, and internal energy. So please imagine right now you are in your room. So your room is your system right now. You are in a system, a room system. So the total energy of the system that you are sitting right now comprise only kinetic. You are moving, you can calculate your kinetic. Potential, to sitting above your sea level, so you can calculate your potential. As long as you are in your room, you can calculate your potential energy. If you are sitting above sea level, for example, 1 meter above your above the floor, above the floor, okay. Then internal energy. The energy here is the energy if you yourself have a molecule inside, so you brings your own internal energy. So you can add on your internal energy, or even your chair, okay, your chair. Since your chair, table, they have a molecule inside, so they actually have their own internal energy. So the total energy of your system, the system that you are sitting right now, comprise of only types of energy: kinetic, potential, and internal. So the symbol of total energy is E, uppercase E, capital letter of E, equal to U is internal energy, plus EK here, kinetic energy. Sometimes we write KE, or E also can, plus E, potential energy. Then proceed to U plus mv square over 2 plus mv kilojoule. This is how we calculate the total energy of the system. Most of the closed systems are stationary. So now, if system is closed, but in a closed system, has any door or room, so the system are stationary. Stationary means constant velocity and gravitational center. So your system is static, or it's moving but the velocity is constant. Okay, for example, fan yang sebenarnya lah, it's not real. Right? We don't have a room that is moving, that are moving. Okay, so just as an example, constant velocity here means either the velocity is 0 or is moving constant velocity. And gravitational center. Gravitational center means on the sea level. Therefore, the change in the total energy is the same as the change in the internal energy. What does it mean? So this sentence is related with the sentence number 2. Constant velocity and gravitational center. So for example, now your room, okay, your room is moving. For example, okay, your room is moving from one position to another position, from position number 1 to position number 2 with a constant velocity. Constant velocity means here at point number 1, the velocity is 10 meters per second. Point number 2, the velocity still 10 meters per second. This is a constant velocity. Okay? So for example, our room are moving from point A to point 2. The level is on the sea level. Okay? On the sea level. So if we want to find the total energy of point 1, at point 1, the total energy is, let's say, E1 plus equal to U1 plus KE1 plus PE1, right? Position number 1. Position number 2, the total energy is U2 plus KE2 plus P. This one equal to U plus KE plus PE. That is total energy. As I said just now, at point number 1, the total energy is U1 plus KE1 plus PE1. At position number 2, total energy is U2 plus KE2 plus PE2. Okay, so therefore, the change in the total energy, the change here means E2 total energy 2 minus total energy 1. Total energy at 2 minus total energy at 1. That is the change. Find, if you minus E2 minus E1, then we will have delta E equal to delta U. Because KE and PE are same. Constant velocity, gravitational center. So we can cancel both. KE1 and KE2. 1 and PE2 are same. So kosong lah jadinya, 0, become 0. So the remain is U1, U2 minus U1 on D. Then we can simplify as delta U. Delta U here means U2 minus U1. This is how we find the change in total energy. Okay. This is the general equation for total energy, right? U equal to U plus KE plus PE. We know KE is 1/2 times mv squared. Mg z. Okay. So based on this equation, find the total energy at position 1. Find the total energy at position 2. Then minus both. Exercise. Determine the power required to accelerate a 900 kilogram car from rest to a velocity of 80 km per hour, 20 seconds on a level road. Okay, so determine the power required. The power required, so we have to find joule first. Work. Find work. So the work is WA equal to 1/2 times mv minus m1 squared. This is the work. Dapatkan kerja, work, and then find the power. Power is work over time, joule over time, and over time. sama lah. Actually this one is same as just now. So your room is moving from one position to another position. Work done calculated by using this. But for this case, the velocity is not constant. Okay? Velocity 1 is 0 and velocity 2 is kilometer per hour. The first situation, as I described in the previous slide, the room has a constant velocity. The velocity are same on position 1 and position 2. But for this case, velocity is not constant. So you have to minus d1. The potential energy for this case, 0. Because on a level road, Gz, Z1 equal to Z2. They are on the same level. That's why potential energy 0. It's not, can be cancelled. How about internal energy? Internal energy, they are same because same car move from one position, from position 1 and position 2, which means the same amount of internal energy. Position 1 and position 2. That's why potential energy equal to 0. Okay. For example here, U1 equal to U2 because same car is moving from point 1 to point 2. For the kinetic energy, the car is moving from velocity 0 to velocity 8t. So that's why 8t minus 0. For the kinetic energy, potential energy, the car is moving on the same level. So Z1 equal to Z2 minus the amount of potential energy equal to 0. So the power is 11 point. Sorry, the energy is 222 kilojoule. Total energy 222. After that, determine the power required. So power, energy over time. So 222 kilojoule over 20 seconds. Final answer is 11.1 kilowatt. Okay, next, properties of a system. So for properties of a system, we have a system. We are on our system right now. Okay. Of us are on our system right now. You are in your system, your room, own system, in my room. So for our system, they have their own properties. Okay. Properties here means the pressure, the volume of our room, the mass of our system, the energy inside our system. All of these are the properties of our system. Now, go further. The property itself have their own types, own category. The first category is intensive. Second category is extensive. Intensive means the properties does not depend on the system size. For example, temperature. The system or our room come double, the temperature of our room still same at 25 degrees C. Room temperature, right? Make our room bigger, temperature still same, right? So that means temperature is intensive, is in extensive category. Does not depend on the size of the system. Same to pressure. If we make our room smaller, the pressure is still 1 atm, 1 atmospheric pressure. So pressure is in intensive category. Does not depend on the size of the system. But for the volume, mass, total energy, it depends on the system size. Make our room bigger, the volume also increase, right? The mass also increase because the room now bigger than before. Total energy also increase because we allocate more, we occupy our room more with devices. So total energy increase. So all of this volume, mass, total energy is in extensive category. Depends on the system size. So specific property is an extensive property per unit mass. Okay. So we have another properties, new properties. For example, specific volume. Specific volume is volume over mass. Then we have specific total energy. Energy over mass. It is called as specific total energy. Last one, specific internal energy, small u. Internal energy over mass. So please remember this: specific volume, specific total energy, specific internal energy. Okay, so far, before we go further, do you have any question to ask me? Ada persoalan? Before we move to the next slide, I will explain to you these properties of a system in terms of another analogy. Instead of using your room, boleh juga kita gunakan room. Okay, for example, I will use another analogy. For example, if you have a cake, okay, a birthday cake right now, in front of you. The amount, the weight, the mass of your cake is 1 kilogram. Round shape cake, round shape, okay, round shape cake in front of you right now, 1 kilogram of mass. Okay, if you cut half for that, the cake is your system. It's a system. Okay. The cake in front of you right now, for example, just imagine that in front of you now you have a birthday cake, round shaped cake, that's 1 kilogram, and this cake is a system. Okay. Volume is, for example, volume is 1 meter cube. 100 meter cube. No. 10 meter cube. 10 meter cube. 10 meter cube. Weight is mass is 1 kilogram. Total energy is 100, for example. Then you have a knife and you cut into half your cake. What happened to the mass? Cut half, right? From 1 kilogram to 500 gram each. What happened to the volume? From 10 meter cube down 5 meter cube each. What happened to the total energy? Of course, become half. Right, 100 kilojoule now become 50 kilojoule each. But all of these properties, mass, volume, and total energy, is depend on the size of the system. So therefore, volume, mass, and total energy is extensive properties. This is how we determine the meaning of extensive properties. Any properties that depend on the size of the system is called extensive property. However, for the intensive, the properties does not depend on the size of the system. Katalah, let's say you have a thermometer and then you check the temperature of your cake. Before you cut into half, you check the temperature of the cake. For example, 20 degrees C. 20 degrees C, the cake. And then you cut your cake into half. What happened to the temperature? Is it become 10 degrees C? Not right. Possible, right? Unless you put your cake into your freezer, then the temperature will reduce. So the temperature still remain at 20 degrees C even you cut your cake into half. What happened to the pressure? Still same. Right? Cut, the pressure still as the initial. Let's say 180 N. You measure the pressure of the cake. For you cut, you measure the pressure of the cake. Let's say the value is 180 N. Then cut your cake into half. Measure again. Is the pressure reduced? It's not. Impossible. And pressure is called intensive property. It does not depend on the size of the system. Okay, this is how we differentiate and determine the meaning of intensive and extensive properties. Okay, next, we often define properties in terms of another properties. Density, for example. Density comes from mass and volume. Specific volume also same like density. It comes from another properties. Come from volume and mass. Right. Specific volume, small v, is actually volume over meter. Volume over mass. So specific volume come from another properties from volume and mass. So we can define most extensive properties per unit mass. Once we the extensive property per unit mass, then their name become specific properties. For example, internal energy. Internal energy is a capital letter of U, right? U besar, uppercase U. That is internal energy. So if you make it per unit mass, dibahagikan dengan mass, then it becomes specific internal energy. Uppercase U or internal energy over mass, called as specific internal energy. This one. All of this is specific property: specific volume, specific total energy, and specific internal energy. Their symbol is small v, small e. Okay. Okay, next is state. This is another term in thermodynamic field. For that, we have another 10 minutes. This is the last one. Not can have a look at my lecture note. State is a set of properties that describe the condition or state of a system. Set of properties. Okay. For example, at a given state, all the properties of a system have a fixed value. Okay. As I mentioned to you just now, you are in your own system, right? So your room is in position 1. Then I said to you, please imagine that your room is moving from state 1 to state number 2, right? From position 1 to position 2. During position 1, your system or your room has their own set of properties, right? Pressure, temperature, total energy at position 1, right? That is a set of properties, state position 1. And your room is moving to position number 2. So during position number 2, your system or your room has their own set of properties. For example, now the pressure is pressure number 2, temperature is now temperature number 2, volume now is volume number 2, so on. So that's situation. The meaning of sentence number 2. At a given state, at a given position, all the properties of a system have a fixed value. If you change a property, have changed the state. Back to your room, during position 1, the temperature is temperature 1, right? And then your room moved to position number 2. Now the temperature become temperature 2. What that means, have changed the state from state 1 to state number 2, from position 1 to position number 2, because you change the property of the temperature. For this, the temperature is T1. Now the temperature is T2. So that means you have changed the state. From state 1, position 1, then now become state number 2, position 2. Number 4, thermodynamics deal with equilibrium state. Equilibrium state here means stable. Equilibrium means stable. Balance. Equilibrium is a state of balance. A system in equilibrium, no changes when it is isolated from its surrounding. If a system is in equilibrium, that means it is isolated from its surrounding. Balance. Changes happen. That is state. Change the property, you have changed the state. So please remember that. From T1 now become T2. That means you have changed the state from state 1 to state number 2. Okay, next, equilibrium. State of balance. No change in the driving force with time. So they have several types of equilibrium: thermal equilibrium, mechanical equilibrium, phase equilibrium, chemical equilibrium. Thermal equilibrium means the temperature is the same throughout the system. While for the mechanical equilibrium, no change throughout the system. Number 3, phase equilibrium. Two phases such as water and ice reach an equilibrium state. So means that the amount of water and the amount of ice are same. Last one, chemical equilibrium means no composition change with time. Okay, next, process, a change from one equilibrium state to another. Back to your room, the analogy of your room. Your room now is in position 1 or state number 1. Then your room moves to state number 2. Now you have two states. State 1, initial state, then final state is state number 2. Okay. The process means that once your room moves from one position to another position, it's called as process. A change from one state to another state. That is a process. So process 1 to 2. That is a process. A path is the series of states the system passes through during a process. So a path is a laluan, a way. Become straight way, it can become a curved way, or it can be vertical way. So we often deal with quasi-equilibrium process. Quasi-equilibrium means near to equilibrium, near to a balanced state. That is a quasi-equilibrium. So processes can be expressed in terms of diagrams. They have several diagrams, diagram, and diagram. So if we want to express the process, we can show in terms of diagram. So for example, here, this is a PV diagram. Diagram of a compression process. Okay, for example, now this is initial state, state 1, and state number 2. So the process is from 1 to 2. This is the process. And this line, straight line, is called as path. It can be straight or it can be a quite curved line. So this is a path. The system is, this is the system, this is the process. 1 to 2 is a process. So process can be classified into 4 processes. They have 4 types of processes. The first one is isobaric, second is isothermal, third is isochoric, and number 4 is isentropic. If the pressure is constant, then the process is called isobaric. So please remember this. Okay? Isobaric process is where the pressure is constant. Isothermal process is where the temperature is constant. Okay? So the temperature is constant. Once temperature 1 and temperature 2 are same, then the process is called isothermal. Number 3, if the volume is constant, volume 1 equal to volume 2, then the process is called isochoric. Last one, entropy. Entropy is a new properties, and this entropy will be discussed later on in chapter number 6. Okay, but for the time being, just know that the entropy is S1. If S1 equal to S2, the process is isentropic. So we will stop here. Let's discuss later on. So before we stop our first meeting, have anything to ask me? What we have learned in chapter number 1. Not, then I will stop this session and see next week, inshallah, on this coming Friday. Okay, so thank you for your attention today. Inshallah, we will meet on next Friday. Okay, thank you. You can get this lecture note from Yulen by today, as well as the list of the group, the plan, sheet. Okay, so see you guys on next week, inshallah. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Thank you, Doctor.
Okay, Doctor.
Thank you, Doctor.
Thank you, Doctor.